Hey everyone, and welcome back to our channel. Today we continue our journey into data engineering and data science within Microsoft Fabric. I'm your host Estera, and I'm delighted to introduce our new guest, Misha, who is joining us to discuss model and experiment training in Microsoft Fabric. Misha, being a first-time guest, we are eager to learn what are your projects, what you are working on. So can you please introduce yourself?
Yeah. Hi, everyone. My name is Misha. I am one of the product managers on the Fabric data science team. I work on a lot of the areas around, how do users train their different machine learning models, to everything around how do they track and collaborate as they're iterating through all these different combinations, and even do all the governance and kind of the integration of how these experiences work in the Fabric platform. So I'm excited to share some of the experiences we have around Fabric model and experiment tracking.
Let's dive right in. So I will start with the first question. What is the difference between an experiment and a model?
Yeah, great question. You can really think of, experiments in Fabric are a source of collaboration, right? Often as part of the data science workflow, you have a lot of different users who might be contributing, they might be trying out different trials. And so you can really think of experiments as where you go to maybe try different iterations, try different parameters for these models, share the results among other users, do some of the built-in comparisons. But then once you've kind of found the right set of combinations, the settings that give you the best results, what you do is you often just take that run. And you say, hey, I'm going to go save this as a machine learning model in Fabric. Machine learning models in Fabric look and feel pretty similar to experiments. But the real big thing and the real big difference is this is where you operationalize your machine learning model, right? So when you want to generate predictions, when you want to generate insights off of that model, we have a very easy way for you to go into that model, say, hey, I'm going to go apply this, and you can easily just generate some of the predictions off of it. So you'll see a lot more kind of capabilities that get added in to really help distinguish these two experiences in the future. But it's different parts of your data science workflow that kind of just dictates whether you start with an experiment or whether you're in a machine learning model.
So can I share that the objective, the goal of experiment is to find the model?
Yes, exactly. Right. It's exactly as the name implies, like you're experimenting with different things, and it's a learning process, right? You're trying to find the best model based off your experiment results.
Got it. Why it's crucial for ML?
Yeah. So, the data science workflow in general, it's very iterative, right? There's not, it's not, you don't just provide one set of parameters and you can kind of just go and launch that. And so often what we find with the data science workflow is that you're trying a lot of different things. And as you're trying it, it's hard to collaborate. You have to be able to share the results. And so experiments are really guided to help users through that experience, right? So it's a single pane of glass where you can track all of the different iterations that you have. You can do kind of built-in comparison workflows to help distinguish, if I wanted to filter on where my root mean squared error is greater than a certain threshold and the parameters were greater than a particular value, it really helps you get down to kind of the meat of understanding the results of the different things that you're trying in your machine learning process.
It sounds that experiment is a research and model is development and deployment of it.
Yeah, that's a great way to kind of think about how you want to distinguish the two.
And we have to have a lot of logging of the parameters, right?
Yeah. Yeah. And so one of the things that we've added in, which I think really helps with that process, and I know for me, whenever I'm like writing like data science code, it's very cumbersome for me to remember like, oh, I need to log all of these different metrics. There's accuracy, there's precision, and all of these different things. Oftentimes I find that I forget to log a parameter and I have to kind of go back to my trial. And so one of the things that we've done is we've deeply integrated what we call Fabric auto logging, or, it's part of MLFLOW as well. But basically what this helps with is automating this logging process, right? So by default, it's enabled in your Fabric workspace, and you can simply just, write your data science code. And as you go through your experiment, you'll find that all these metrics, parameters, the model files, the environments, all of that is just automatically logged for you. So it really kind of helps simplify some of that pain that you have when you're going through your data science process and trying to remember how you got to a particular result.
So we have to know experiments, models, and now you introduced MLFLOW. We will jump in a second, but also it's somehow connected with MLOps that we'll discuss in the future. But maybe it's the time for MLFLOW for those who are hearing that for the very first time. What is MLFLOW
Yeah.
and how we, like Microsoft Fabric, are providing the integration with MLFLOW?
Yeah, so MLFlow is an open source framework. It comes from the broader data science community, and what it really targets is helping with this, providing a central framework for how we track, how we generate and package these models. And so MLFlow has a very kind of established SDK, set of APIs to kind of govern this process. And what's really great about this is if you're coming in from other platforms, it's kind of becoming like the de facto standard. And so if you're coming in from Azure ML and you want to be able to log things with MLflow and Fabric, it's the same set of APIs, the same kind of mechanisms that you might be familiar with. And so it really helps with creating more reproducible results, packaging these models in a way that's very easy, once you want to deploy it. So you don't have to worry about the format of the models and the, how it gets handled for deployment. With MLflow, it's kind of a standard way for you to operationalize, package, track all of these things. So it's really cool.
Let's show everyone the demo how to set up MLFlow for model and experiment tracking within Microsoft Fabric.
Sounds good.
Today, we'll see how we can use MLFlow to efficiently track experiment results and train an ML model on the housing price dataset from sklearn. We'll use MLFlow to help streamline our model development process and even enhance how we manage these models through their workflow. Now, for this specific project, we'll start with the housing price data set from sklearn. We'll plan to use a variety of machine learning algorithms to predict the housing price, and we'll use different features from the data set, such as the age of the house, the number of bedrooms, the population, and so forth. Now, when we jump into our experiment or model development process, one of the first things that we'll interact with is what we call a machine learning experiment. One of the most common pieces of feedback we've heard about the data science workflow is that it's often challenging to be productive. In Fabric, experiments are the main unit of collaboration for this process. Experiments are essentially a collection of related MLflow runs. And using experiments, we can basically use this to log and organize the results of our experiment. Each time we train a new run, MLflow logs key information such as the hyperparameters, the metrics, the artifacts, and more. And this essentially allows us to easily compare across these different runs and really easily identify which set of configurations or approaches worked best for this particular machine learning task. To create an experiment, we simply need to call mlflow.setExperiment. If the experiment hasn't already been created, MLflow will create a new experiment with a provided name. And then if an experiment already exists, MLflow will simply set it up and allow us to add these new runs to the existing experiment. Now let's take a look at a simple example of how we can use MLflow. In this code cell, we instantiate an MLflow run using mlflow.startRun. This step creates a container that allows us to log all of this essential information about this run. Our next step is to train a KNN model. Here we've set a specific set of hyperparameters for the number of neighbors and the leaf size, and then the rest of the code cell basically allows us to fit the model to our data sets and then evaluate the performance on both these data sets. And so one of the steps I'd like to highlight is how we actually log these different metrics. Here, using mlflow.log metric, we can log things like the R-squared value for both the training and test data sets. We can also add additional metric properties for things like the root mean squared error to better assess the model's prediction accuracy. All of these different metrics that we're logging essentially allow us to provide better insight into the model's performance. But in certain occasions, you might also want to generate plots or other, insights to be able to better understand the model's behavior. And so here I've created a histogram called hist.png. And by using mlflow.log artifact, I can also save the results of these different visualizations that I've created. This is really helpful if I want to later, compare this or allow other users to get access to the different runs that I created. Last but not least, I can also log things like the parameters the model files themselves. And one thing to note when I'm logging model files is I can also apply or provide a signature, which basically allows other users to understand what are the model inputs or what are the outputs from this model as well. And last here, I'll just register this model, and we'll talk a little bit about the model items in Fabric later on, but a very simple, MLFLOW command just to set this up as well. I also wanted to show one more example. And so often as part of our machine learning workflow, we're not just training one model. We're often, trying a lot of different hyperparameters, a lot of different configurations to see what's going to give us the best results. And so here in this code cell, we've set up this code cell to basically explore a range of parameters, including things like the number of neighbors and the leaf size. As we go through each of these different combinations, we basically want to track the specific metrics and parameters that are part of every model that we've attempted. This is particularly useful if we want to collaborate with other users later on, or review our results and see what might have worked or what didn't. And again, using the same commands, I can train the model, I can log the metrics, the parameters, and track the models as well. One of the other things that you can use from the notebook is the inline authoring experience to track and compare the runs from each code cell. And so here I have all of the different model or run iterations that were created, and I can customize this view to look at the precise results, the metrics that I want to see. I can add the parameters that I had changed for each different iteration. Here I can do a visual comparison to see what set of metrics or what parameters gave me the best results. I can also switch into the comparison view to get a more chart-like or visual representation of some of these results as well. And so while this helps me compare the results in my notebook or cell, I can also use the Fabric experiment item to collaborate with other users, or even gain access to what other runs might have been attempted outside this notebook. And so let's take a look at that experiment. Now, one of the benefits of using Fabric experiments is that it enhances collaboration among team members. With experiments, everyone can access a centralized repository of the runs and view the corresponding metrics and models that were then generated. This allows us to make sure that everyone that's collaborating on this project is on the same page, and we can also more efficiently share our own findings and our insights. And so now within an experiment, we have a few different things. Each run here represents a collection of metrics, parameters, and input and output schemas. Within each run, we can also look at the corresponding artifacts that were logged as part of our MLFLOW notebook. We can also look at things like the underlying environment files, which help us replicate this particular experiment and make sure that we have the corresponding dependencies also available. Now, one of the things that we often do as part of our data science workflow is that we have a lot of runs that might get generated. And so if we want to do a comparison to understand what sets of runs or what things might have yielded the best results, we can switch over to the run list view. And from this, we can apply different filters using the same kind of Power BI-like controls that you might have seen. And so here I'm going to apply a filter to make sure that the run status and just look at the runs that have been completed. I can also apply filters on various metrics, on the parameters themselves. I can customize these column views, and I can also use some of the built-in analysis capabilities to update and view tabular information about the different metrics that I have and how they correspond to the runs that I've seen. Now, typically once we've gone through our process and we've analyzed our runs and figured out which run we might want to be able to save as our final model, we can then go ahead and save this run as a machine learning model. And so once we've saved this model, it's then versioned and updated so that we can later reuse this model for deployment and for more ease of tracking. And so let's take a look at what some of these models might look like. ML models allow you to track various iterations of the model. This is particularly useful if you have, say, multiple models that were generated for deployment, or if you have flows that retrain the model and you want to validate it before they get deployed. And like runs, you can also examine each of the different metrics, parameters, and schema that are tied to a specific version. You can also compare models using the model list view. So here, when I switch over to the list view, I can easily compare across the different model versions using the tabular view or the graphical view below as well. Now, one last thing I wanted to highlight is as we switch back to the details view for one final use case, and that is MLFLOW offers a convention for packaging machine learning models in multiple flavors. And so as part of this, as the model is automatically packaged, it makes it very easy to use in downstream workflows where you want to later apply this model version for predictions. And so here in Fabric, you can use things like Fabric Predict. And there's a separate video that covers this in detail, but this is really one of the main capabilities that distinguishes the model and experiment scenarios. Now, let's take a moment to explore how machine learning models and experiments fit seamlessly into the Fabric platform. Within the platform, we've ensured that users can use familiar RBAC methods to grant and manage access to data science items within their workspace. In addition, we've also added an additional layer of security by integrating these artifacts with Fabric sensitivity labels. This basically allows users to identify and classify potentially sensitive model and experiment items in their workspace. And that's not all. So these artifacts are now also incorporated into the Fabric lineage view. This means you can easily trace back and see the entire journey of your machine learning and data science artifacts. This includes the ability to trace back with things like Lakehouse and notebooks that contributed to the creation of these ML items.
That is impressive, detailed demo. I want to follow up on one topic. You mentioned lineage, MIP, and managed access. How those artifacts are managed in Fabric?
Yeah. And so, as part of the Fabric ecosystem, we have a lot of different items, right? There's Power BI reports, there's Lakehouse. And so you really want to think of models and experiments as, just any other artifact or any other item in Fabric. And so as part of that, you saw a little bit in the demo about how Lineage kind of ties all of these items together, right? So you can look at from Lakehouse, the notebook that was run that read in, data from the Lakehouse to how it was eventually pulled into an experiment and model. And so, these kinds of experiences about how we stitch together the story across all of these Fabric items, that's a key part of how these items even play into the broader ecosystem. In the same way, when you think about things like RBAC or, sharing, it'll be a very consistent kind of experience across each of these different items. And so whether you're interacting with a Lakehouse, whether you're interacting with an experiment, it's the same look and feel. And kind of behind the scenes, we want to create that platform consistency. And so you can kind of see how these things interact with each other.
What about any caveats, limitations, challenges, anything what we should be aware of as users of MLFLOW, Microsoft Fabric Data Science?
Yeah, that's a good question. When you go through the MLFlow APIs, for the most part, we've tried to be pretty consistent among the APIs that are supported in MLFlow and things that are supported in Fabric. We do have some exceptions, right? So things like being able to rename a model is kind of some of the limitations that we have.
So what are the upcoming features? You mentioned REST APIs coverage. What else?
Yeah, so some of the things that we're starting to take a look at and work on is things like different AutoML experiences and how they play a role with the MLFlow experiences that we have. So we want to help kind of users go through their machine learning workflow, kind of help prototype different use cases. And so as part of that, what we're really taking a look at is how we kind of build these into the Fabric artifacts that we have. Some of the other capabilities, we have scenarios where people want to log things across workspaces. So whether it's within Fabric workspaces or you want to log to other kind of environments as well. And so we're working on opening up some of our MLFlow endpoints. And so you'll actually be able to start logging across workspaces soon.
So we have a growing number of data scientists who are looking for one perfect platform that will simplify their development. Could you recommend any resources for those users?
Yeah, we have a lot of great samples that are available even within the product experience itself. So if you go to the data science homepage and you click on the AI samples, you'll see a lot of great examples on things like from churn, recommendation models. It's a great way to get started and kind of familiarize yourself with some of the Fabric experiences. If you go to the Microsoft Docs, we also have a lot of documentation on different tutorials. So if you want to go through what could be like an end-to-end data science workflow, right? Everything from your data prep using Data Wrangler to training the model to operationalizing it with Fabric Predict. Some of those tutorials kind of cover that whole workflow. So if you want to kind of get your hands familiarized with kind of that full cycle, I think that's a great place to start with as well.
That's all for we have for today. If you enjoyed this episode, be sure to hit the like button and subscribe for more content. If you have any questions, please comment or reach out to us directly. And until the next time, happy flow with MLFLOW. See you.
Great. Thanks.